Welcome and hello. This is a video lesson in the HEC RAS controller. We're going to be talking about results from every cross-section in a reach. In this lesson, we'll learn how to use the output underscore reach output subroutine within the HEC RAS controller to get the model results for an entire reach. Right here on the screen is my reach with a number of different cross-sections. So there's also a lateral structure and a bridge. But we're going to be focusing on the cross sections because this particular subroutine focuses and returns the data for the cross sections you're seeing right here. All right, so let's go ahead and run the model. This is a 1D unsteady flow model. I'm going to go up to Run Unsteady Flow Analysis. We're going to look at the results in just a moment using the HEC RAS GUI, and then we're going to replicate those same results by using the HEC RAS controller and printing it to an Excel worksheet. Right, so I'm going to go up to View and Profile Summary Table. Here is that table right here. And what I'm going to do is I already have a specific profiles toggled on. I'll go ahead and clear all and then click on Max Water Surface Elevation. So this is the screen you'd probably see if you haven't already changed any of your settings. But what I want to do is take a look at all of the cross sections you're seeing here. Of course, not the one with the bridge or the lateral structure, but all the other ones that have a profile listed. And instead of maximum profile, let's go ahead and change that up. So options, profiles, I'm going to remove that one by double clicking. And then how about we look at the profile after 3 hours, after 6 hours, and after 9 hours. So the number to the left here is the profile ID, which is 511. We're going to need that information a little bit later when we get to the HEC RAS controller. I'm going to click OK. So now for each cross section, this is the topmost cross section at 1000. This is the cross section at River Station 960. This is the cross section at River Station 900, 800, and so on. Within each cross section, there's 3 different profiles. This is after 3 hours, this is after 6 hours, and this data here is after 9 hours. So you can see that we have some different numbers for flow rate, the minimum channel elevation, water surface elevation. I'm going to also pick out a few of these variables, but not all of them. Let's go ahead and use water surface elevation, velocity of the channel, top width, as well as fluid number of the main channel. In fact, I'm going to go ahead and just modify this table right now. So options, define table. I'm going to click on all of the columns I don't want. So that's column 1 for flow rate, and then click on delete. Minimum channel elevation, delete. We do want water surface elevation, so I'll just toggle over here to the next one, column 2, delete, delete, delete. Okay, velocity in the main channel, we want to keep that. Flow area, delete, top width, and fluid number. So if I click OK, this greatly simplifies our table by just reducing about half of the columns. I'm also going to just save this table so that we can reference it later if we need to. I'll call it lesson 25 and click on OK. So now user table lesson 25. These are some other user tables I defined earlier, but boom, now we can go back to the main standard table and then the lesson 25 table right here, just as we defined it. Okay, let's try to create this exact same table using the HEC RAS controller in the VBA script. So I'm going to bring up my Excel worksheet. This is a template that I've already got started, so we're going to go with this. River ID is 1, reach ID is 1 because there's only one river and one reach. Now for the profile IDs, this is the time step after 3 hours, 6 hours, and 9 hours. If you remember, those numbers for an ID were 5, 8, and 11, respectively. And then the variable IDs, I have them lined up here. So water surface elevation has a HEC RAS variable ID of 2. And then the velocity in the main channel, that has a HEC RAS variable ID of 25, top width 62, and fluid number is 48. I should probably mention that these variable IDs are not just coming from anywhere. They are embedded within the HEC RAS code. If you're curious about the master list of the RAS ID variables, go check out my lesson 12 where I use the output underscore variable subroutine to list them all out. And I'll leave a link to that video in the description of this video. So with that set up, what I'm going to do is print out the results down below. River Station is going to start at 1000, and it'll be 1000 for all 3 of our different profiles. So the next column over for profile, this is going to be like 3 a.m., and then 6 a.m., and then 9 a.m. And then it's going to repeat. So we'll add an extra row here just for visual separation. And then the next cross section is at River Station 960, I believe. So we'll have 3 of those. And then the 3 profiles will also repeat as such. And then 900, and then all the way down to the end of the reach at River Station 0. We're going to be using the HEC RAS controller's output underscore reach output subroutine to extract the data for water surface elevation, main channel, top width, and the Froude number for the main channel. And you're going to see that in action right now. So I'm just going to delete this. Let's double click on the developer tab to expand, and then click on Visual Basic. Okay, so right now I have my worksheet selected. I'm going to just write code in the worksheet right here. First thing I'm going to do is paste in a subroutine, which is going to open up our project file by passing in the HEC RAS controller and then opening up the file. Okay. The rest of the code is right here. It's everything from this right here. I'm calling this get reach data. And let's see here. First, we're going to clear our results. Then we're going to create the HEC RAS controller object and then open up the project by calling create controller. After that, I've got some utility variables, just like random integers that are used for iterators, row, column, and count. So we'll be using those a little bit later. Next, we're assigning the river ID and the reach ID. So cells 2, 4, and 3, 4 are over here in the worksheet, 2, 4, and 3, 4. So those values are just quite simply 1, both. After that, if I scroll down, we have profile IDs and variable IDs. So what I'm doing there is creating a profile IDs array that's a long, as well as a variable IDs array also a long. I'm going to be reading in these numbers here. So 5, 8, and 11 for the profile IDs. And then for the variable IDs, it's going to be 2, 25, 62, and 48. So we're going to be looping through the profile IDs and through the variable IDs as we're populating our table. Okay, let me just minimize that and go back to the VBA. All right, so next we're doing is dimensioning of variables that are used in the output underscore reach output subroutine. This is the one and only procedure we're going to be using to extract all this data. All right, so RS count, that is a long, that's the number of records. RS value is a string, that's an array. That is the river station written out. And then the DS distances, this is the distance to the next downstream cross-section, which I'm not actually going to be using, but I have a placeholder for it anyway. And then finally, variable values. This is a single data type array, and this is the array that's actually going to be holding the values of our specific variable, whether that's water surface elevation or Froude number or top width or the main channel velocity. All right, after that, we're going to begin looping through the profile IDs. So the profile IDs right here is going to be 5, 8, and 11. So we're going to be using profile ID. We assign it right here, 5, 8, and 11. We're going to print out either 3 p.m., or sorry, 3 a.m., 6 a.m., or 9 a.m. just as a string. That's going to print out to the worksheet, and we'll see that a little bit later. Then what we're doing here is we're looping through all of the 4 different variables. Var IDs is our values for right down here, 2, 25, 62, and 44. So we're going to print those out in columns 4, 5, 6, and 7. So if we go to the worksheet, we have 4, 5, 6, and 7. Now for each loop, it's going to be basically the same thing. It's this var values. I'm actually reversing both of those arrays because the subroutine assigns them in ascending order, and the table that we're trying to mimic right here has those river station cross sections in descending order. So I'm just trying to make my results look as equal to the HEC RAS data table. That variable ID is assigned right here. And then here are the parameters to our subroutine to get that data, which is the controller dot output underscore reach output. All right, finally down here, we're printing the results. So let's see, columns 2, 3, and column are going to be printed out. This value is going to change based on the column, which is going to be incrementing from 4 to 5 to 6 to 7. And that's true for each profile. All right, so that's where we're looping through the profiles first and then the variables within the profile. You may have noticed a couple helper functions like extract RS. What that does right down here is basically take a string that is the river name, space, reach name, space, and then the river station number, and it extracts just the river station number. Basically, any text after the last space, that's what that one's doing. And then here is that reverse array function that I called earlier. So yeah, let's go ahead and give this a shot. I'm going to click in there, reset, save, and then let me pull this to the side. Here is our Excel file. So let me go ahead and just go with run and then run the subroutine. Boom, there is our results. So we have our river stations that are listed down in the downstream direction, starting with 1000, 960, 900. After that, we have the flow profiles. I could have included the day and the month, but I just included the hour because this is a 1 day simulation, so there's no need to repeat the month and the day over and over. Right, so we have 3 a.m., 6 a.m., and 9 a.m. for each of the different cross sections. And then, of course, here is the data: water surface elevation, main channel velocity, top width, and the fluid number. Let's go ahead and bring that table up just as a comparison here. So, okay, I had to move some stuff around, but I think we're good now. So 521.97 is right here, 521.97, 524.49, 524.49, 523.16, 523.16, 521.71, and so on. So that's water surface elevations. Let's go ahead and take a look at main channel velocity. We have 15.41, 17.52, and 13.91. That is 15.41, 17.52, 13.91, and so on. And then top width and the fluid number, you can go ahead and observe and check for yourself. I'm not going to be checking every number. I did enough spot checking to convince myself that this is indeed correct. So while you're using HEC RAS, you can of course go up to the view and profile summary table and get all sorts of data right here. But if you wanted to do the same thing and get this data directly into your Microsoft Excel for your reports, for your post-processing analysis, maybe you want to add some data that's from outside of HEC RAS, you can do that very easily by using the HEC RAS controller, specifically the subroutine that we looked at in this lesson, which was the output underscore reach output subroutine.